Good morning, everybody. Yesterday, we learned how do we solve a linear inequality in one variable. Let's practice what do we have learned yesterday. Look at this inequality. Left-hand side, -3 times parentheses x plus 5 is bigger than right-hand side. Right-hand side is x plus 7. So let's take a couple minutes to solve this inequality. I'll give you a couple minutes to work on it. Let's recall the rules we have learned yesterday. The only difference between solving a linear equation and solving a linear inequality is when we multiply or divide both sides of the inequality by a negative number, we need to switch the direction of the inequality, right? Everything else is the same with solving an equation. When we solve an equation, we start from simplify both sides separately. And then we can move around those terms to collect the like terms and combine like terms. Eventually, isolate x on the left. Please work on this first on your own. Start from simplify the left-hand side and right-hand side. Left-hand side has a parentheses, right? Left-hand side apply distributive property. Formula for distributive property, A times B plus C equals A times B plus A times C. And look at how many terms do we have. And you want to try transposition of terms in this case as well. That's minus 50, right? You want to isolate the x, so you get move this x to the left-hand side and move negative 50 to the left. The distributive property, copy the problem first. Distributive property, look at the formula. Coefficient is A, so A times B plus C equals A times B plus A times C, right? So you're going to use -3, yeah, multiplied by x. You have -3x. And -3 times 5, so you have -15, right? Very good. And copy bigger than, bring down the symbol on the right hand side. Bigger than, yeah, copy x plus 7. So is that clear this thing? So now you look at the inequality. You have 1, 2, 3, 4, 4 terms, right? You want to isolate x on the left, so you want to move this one over, move this one over, right? So you move this one over, you have -2. Yeah, when you divide by -2, yes, you have to switch the direction of the inequality symbol. So distribute. Yeah, so good. Yeah, you want to move x over. Remember transposition of terms. Move -15 over. Because you want to isolate the x on the left. So you want to collect the variable terms on the left first. right? So you want to move this x over? You didn't move it. Or you moved positive 15, but you moved negative 15 over, okay? Oh, okay, I got you. Yeah, that's correct. You can use this method as well. And then you wanna minus x for both sides. Hold on here. When you move x over, you need a negative x. You don't have time.
The x on the right side to the left side.
Yeah, or you can use your method, minus x from both sides. Yeah, minus x from each side. You guys have an answer? So how do you get a negative 3x? Negative 3x minus x gives you negative 4x. About you. Let's look at this problem together. I told you we're gonna have test 2 this week, right? So you guys need to practice. Let's look at this inequality. Firstly, we simplify both sides. This inequality symbol, I copy it. Left-hand side, negative 3 times parentheses x plus 5. I apply distributive property. Negative 3 times x, negative 3x. Negative 3 times 5, negative 15, right? That's the left-hand side. Right-hand side, we bring down the 2 terms because nothing to simplify. Nothing to simplify. Now look at the inequality. We have 2 terms on the left. We have 2 terms on the right, right? So we have 4 terms in total. We want these 2 terms on the same side because they are variable terms, right? And we want these 2 constants on the right-hand side. Then we can combine them. The goal is clear, right? So how do we do that? We can use transposition of terms, or we can use the addition property. For example, you can minus x from both sides. Minus x from both sides, right? Then these 2 cancel, correct? Yes or no? Then on the right hand side, you have 7. On the left hand side, what's negative 3x minus x? 4x, that negative 4x, negative 3x minus x, negative 4x. Bring down negative 15. How do you get rid of negative 15 from the left hand side? You plus 15 to both sides, right? And negative 15, positive 15 cancel each other. On the right hand side, we have 7 plus 15, that is 22. On the left, we have negative 4x. Right? And then we're gonna divide both sides by negative 4. Divide both sides by negative 4. Divide both sides by negative 4. Do we need to do something special? Change the direction of the inequality symbol, right? Yeah. Negative 4x. We divide the left hand side, negative 4x by negative 4. Right hand side, 22 by negative 4. But we need to remember to switch the direction of the inequality symbol. We emphasized this yesterday. Okay. Left hand side, negative 4 cancel negative 4. So we have x isolated on the left. On the right, we have a positive 22 divided by negative 4. So the quotient should be negative, right? 22 over 4. Both 22 and 4 are even number. So they divisible by 2, correct? Divided 22 by 2, we have 11. Divided 4 by 2, we have 2. Do you see that? So once you isolate x on the left, you should have x is strictly less than negative 11 over 2 or negative 5.5. Yeah, It doesn't hurt to convert it to decimal, right? Negative 11.5, 11 over 2 is negative 5.5. Let's graph the solution set. So this is the real number line. Let's say negative 5.5 is right here. So are we gonna go to the right or go to the left? Solutions are less than negative 5.5, right? Go to the left. We go to the left, right? Right or left? Left, yeah. What about at negative 5.5? Have a parenthesis or bracket. Why do we have a bracket? So do we use a parenthesis or bracket? Parentheses, right? Yesterday we learned this because this point is excluded. Negative 5.5 is not a solution. Does that make sense? So when the end point is excluded, we use parentheses. Otherwise, if the end point is included, we use bracket. How do we write a solution set in the, yes? On the what?
On the number line, what the parentheses there?
Because, yeah, I used to use a circle because the one, the test paper, the test bank, all the answer choices describe the graph like this.
Okay.
Because of that reason, yeah. Yes? How do you know if the answer is a solution or not? You have to find your solution and look at which one is the same with yours. You need to solve this inequality and find a solution set. And look at the answer choices to choose the one with same with yours. Did I answer your question? That's one whole piece, right? So that is one interval. Tell me what's the left end point. Left end point. Left end point. Over there, what's the bound? Yeah, negative infinity. What's the right end point? Negative 5.5 or negative 11 over 2, right? And we use a comma to separate them. Parentheses, frame infinity. At negative 5.5, we use parentheses when we graph the solution set, right? Same thing here, use parentheses to frame the right end point. Because the right end point is not included, it's not a solution. So you should choose this as the answer, okay? You should choose this as your answer, okay? You guys need to practice. I walked around and I think you guys really need to practice a lot. Now let's move to example 2. Yeah, yesterday we did example 1. Example 1, all those inequalities only have one inequality symbol, right? Yeah, we did those 4 problems yesterday. Now let's look at example 2 in this section. Let's look at example 2. Number 1, negative 7 is less than x minus 1 is less than 10. Number 2, 2 is less than or equal to negative 2x, less than or equal to 4. Yeah, this is a special. What's special? Look at the first inequality. We do one at a time. Yeah, the first inequality, left-hand side is negative 7, right-hand side is 10. In the middle, we have x minus 1. This expression has 2, more than 1 inequality symbol, right? So in this inequality, we have left-hand side, the middle part, and the right-hand side. We have 3 parts in the inequality. Do you see that? Okay. This type of inequality is called a compound inequality. Compound inequality. Yeah, you will have at least one problem on the test 2, which is to solve compound inequality. Yeah, let me explain why we call this kind of inequality compound inequality, because this inequality has two parts, this part and this part. Yeah, the blue circle part means -7 less than x minus 1. And be careful, the logical connective here is and x minus 1 less than 10. So this inequality is the combination of those two inequalities. So we call this type of inequality compound inequality. Does that make sense? Yeah. The solving actually is not very complicated. The solving is pretty straightforward. Remember, when we solve a linear inequality in one variable, I always draw a bubble and I write something in the bubble, right? Yeah, what did I write? Where? On the left, right? But when we solve a compound inequality, our goal is to isolate x in the middle. Okay? When we solve a compound inequality, our goal is to isolate x in the middle. Okay, this is the left-hand side, this is the right-hand side, this is the middle. Left and right do not contain x at all. That's easy, yeah. So you see the compound inequality is a complicated topic. However, the examples and the problems we handle are pretty simple. Left-hand side, right-hand side do not contain x at all. X only is contained in the middle. Yeah, so our goal is to isolate x in the middle. Let's see what's in the middle right now. In the middle right now is x minus 1, right? Yeah. Yeah, so we have a -1. We don't want a -1 there because we want to isolate x, right? We want x be there by itself. So we need to get rid of this part. How do we get rid of this part? By the way, when we solve compound inequality, do not apply transposition of terms. Yeah, I did try very hard to solve you this method, transposition of terms, but do not use it for compound inequality, okay? It does not apply in compound inequality. So in order to get rid of -1, what are we gonna do is we plus 1, right? Yeah, we add the opposite, yeah. We're gonna do the same thing to all the three parts. We add a 1 to the left, we add a 1 in the middle, we add a 1 to the right. Let's see what happened after this. Left-hand side, -7 plus 1, what do we have? -6. And bring down less than. In the middle, x minus 1 plus 1. That's how do we isolate the x in the middle, right? -1 and 1 cancel. On the right, what is 10 plus 1? Obviously, it's 11, correct? Yeah. Once you have x isolated in the middle, you have the solution set already. Let me interpret the result here. The result tells us this compound inequality has solutions. Those solutions are between -6 and 11. In other words, the solution set of this compound inequality contain all the real numbers bigger than -6 and less than 11. Yeah, any real numbers between -6 and 11. Those are the solutions of the original compound inequality. Am I clear? Does that make sense? Okay. So let's see, how do we graph the solution set in a real number line, and how do we write a solution set in the interval notation? That's the whole thing. We have always to do that. This is a real number line. X has a lower bound, which is a -6. Let's say -6 is right here. Has a upper bound is 11. Let's say 11 is right here. Okay. How do we graph the solution set? All the real numbers between -6 and 11. All the real numbers between -6 and 11. Okay. At -6, I want to ask you, is -6, this number, -6 itself, a solution of the compound inequality? Yes or no? Yes or no? If you plug in x equals -6, would you have a contradiction or true statement? Huh? Contradiction, yeah. Look at this inequality symbol. Strictly greater than, okay? Yeah, the real numbers strictly greater than -6. It didn't say equal to, right? Yeah, so -95.999 is okay. Even just a little bit bigger than -6 is okay, but not -6. So tell me again, is -6 a solution or not? No, yeah. So means -6 is not included in the solution set, right? So we're gonna have a parenthesis or bracket here. Yeah, parentheses, right? Let's look at the right endpoint or the upper bound of the solution set 11. Is 11 a solution of the inequality? You tell me. Same thing here. Look at the inequality symbol. It's strictly less than 11, right? Yeah, all the real numbers are strictly bigger than -6 and strictly less than 11. Solution set does not include 11. Do you see that? Yes or no? Okay, so are we gonna have a parentheses or bracket at 11? Parentheses, yeah, parentheses, okay, yeah. So this is an open interval. Yeah, left open, right open as well. This is an open interval. I define interval as one whole piece on the real number line, right? So look at the solution set. It is one whole piece, one single piece. So that's one interval. Let's see what's the left and the point of the interval. Left and the point. What's the left and the point? What's the right and the point? Yeah, we use a comma to separate the left and the point and right and the point. At -6, because -6 is not included in the solution set, we have a parenthesis. Same with 11, we have a parenthesis here as well. So this is the answer you are going to choose if this problem is on the test. Okay? So the solution set is an open interval. All the real numbers between -6 and 11, both -6 and 11 are excluded. They are not part of the solution. They are not the solutions. Am I clear about this problem? Any question? Yeah, number 2. Let's see number 2. Number 2 is 2 less than or equal to -2x less than or equal to 4. This is a compound inequality as well. In the middle, we have -2x. On the left, we have 2. On the right, we have 4. 3 parts in the inequality, right? Okay, so I'm gonna draw a bubble. What do you think I'm gonna write in the bubble? Isolate x where? In the middle, good. In the middle, exactly. Yeah, because we are solving a compound inequality, right? Yeah. In the middle right now, we have a -2x. We need to get rid of this -2. How do we get rid of the -2? Plus, minus, multiply, divide. Divide, right? Yeah, divided by -2, right? Okay, so we are going to, in order to isolate x in the middle, we are going to divide everything, all the 3 parts by -2. Divide the left-hand side by -2. Divide the middle part by -2. Divide 4 by -2. Okay, we are dividing by -2. We are dividing an inequality, even if it's a compound inequality, it's an inequality. We are dividing inequality by -2. So something special we need to do. Flip the inequality symbol, right? Less than or equal to becomes bigger than or equal to. Less than or equal to becomes bigger than or equal to. Do you see that? Yeah, okay, it's very important. Even is a compound inequality. The rule we learned yesterday still applies. Every time when we multiply or divide inequality, yeah, left-hand side or right-hand side or even in the middle, depends on how many parts in the inequality. We have to flip the direction of the inequality symbol. All right, after this, in the middle, because -2 cancel -2, in the middle we have the x right now, right? On the right-hand side, what is 4 divided by -2? -2, right? Yeah. On the left, what is 2 divided by -2? -1, -1, right? Okay, so now I'm gonna change this inequality. I'm gonna write this inequality in a different way. I'm going to write this inequality as bigger than or equal to -2 and less than or equal to -1. And you tell me, are they the same? Yes, the alligator mouse also fits to the bigger number -1, right? Then why did I bother to rewrite the inequality like this? Because by convention, it's like the real number line. On the real number line, when you look at the numbers or points on the real number line from the left to the right, they are getting bigger and bigger, right? So we want to follow that direction. So we want to have, when we look at the inequality from the left to the right, we want to go from the smaller quantity to bigger quantity. And that's the reason we like to write the left-hand side as a smaller side, the right-hand side as a bigger side. Does that make sense? Also, this is easier for us to understand or incorporate the result. The solution set of this inequality, compound inequality, includes all the real numbers bigger than or equal to -2 and less than or equal to -1. All the real numbers between -2 and -1, including the two endpoints. Do you see this? Less than or equal to, less than or equal to, right? So in this case, -2 is a solution. Do you see that? -1 is also a solution. Do you see that? Let's graph the solution set. Where is -2? Where is -1? Which number is bigger? -1 is bigger, right? So where's again? Okay. So all the real numbers between the two numbers, including -2 and -1. -2 is a solution, is included. So we're gonna have a bracket here. Same with -1. -1 is a solution, is included. So we're gonna have a bracket here. The solution set is a closed interval. Left-hand point -2, right-hand point -1, comma to separate. Left-hand side, I mean at the left-hand point bracket, right-hand point bracket as well. Okay, am I clear about this? Compound inequality. You need to try to isolate the x in the middle. Also, you have to graph the solution set and write the solution set in the interval notation. Any questions? Any questions? Okay, your turn. This one is yours. Oh, hold on. Let me give you another different one. Let me actually look at this. Okay, I'll give you a couple minutes. Please work on number 2.
How do you isolate X in the middle? That's correct. Can you graph the solution set? Can you graph the solution? After you isolate X in the middle, graph the solution as well. Then you divide all the parts by 3, right? So you have X in the middle, 10, 4, that's correct. And you have to bring down, copy the inequality symbol. You don't change them. Because you're dividing a positive number. Remember, you only switch the direction of the equals to negative. But this is a positive, right? Yeah, you can split the direction. Yeah. Because you are dividing a positive number. Okay, so you see this, what does this mean? This means X is bigger than 4, because it could be 4.001, but it cannot be 4. This is X less than or equal to 10. Four is not a solution. Yes, 10 is a solution because less than 4 equal to 10. Feel the meaning. And the graph it. You're gonna have 4 on the left, 10 on the right, right? Actually, it doesn't matter because this is right. This one here is a file. And choose 1 point. And then how do you graph the in the middle? Yeah, graph the middle first. Our real numbers choose 1. All the real numbers choose 1. I use different color. I use red, right? So I have 4. Probably I have 4. Depends on 4 is solution. 4 is not a solution. Look at that. 10 is yeah. Let's look at yeah, exactly. Good job. It is a rule that we have to remember and follow. If the endpoint is a solution, we use a bracket. If the endpoint is not a solution, we use a parentheses. Let's look at this problem together. It's a compound inequality. We are trying to isolate X in the middle, right? Yeah, most of you know we're gonna divide all the 3 parts by 3. But do we need to switch the direction of the inequality symbol this time, in this case? No, because we are dividing by a positive number. Yeah, in the paragraph you copied down yesterday tells us we only need to switch the direction of the inequality when we multiply or divide by a negative number. Positive, we do not do that. Okay, so in the middle, we have X. Copy less than or equal to. On the right, we have 10. Copy less than. On the left, we have 4, right? Yeah, so let's graph the inequality, the solution set of the inequality. Let's say 4 is here, 10 is here, right? All the real numbers in between, all the real numbers in between, all the, Sorry, this is too much. All the real numbers in between. And 4, tell me, is a 4 a solution or not? So parentheses. Tell me, is a 10 a solution or not? Bracket. So on Friday, when you see something like that, you know that's what I'm gonna choose, right? Okay, so let's write the solution set in the interval notation. What's the left endpoint? Right endpoint, parentheses, bracket. Okay. Any questions? I have the interval notation right here. We can take a look. You see, I do used to use the circle and the solid dot, but in our test, we have a parentheses and a bracket in a graph. So I changed my notation. So this means open interval A, B. This interval includes all the real numbers between A and B. A and B are both excluded because A and B are not solutions, are not in the set. The next one, left endpoint and right endpoint, both A and B are included, so that is a closed interval. This one, A is excluded, B is included, so it's a left open, right close. The next one is left close, right open, so it's a half close, half open interval as well. And this one, left endpoint is net infinity, right endpoint is B. B is excluded, so it's an open interval. This one, left infinity, net infinity to B. B is included, so we have a bracket at B. This is A to positive infinity. A is excluded. And this is A to positive infinity, left close, right open. All right? Okay, let's see what else in this section. Solving linear inequality. So I'd like you to practice more inequalities here. Try this one. Take your time, take your time. Solve this inequality. We have a less than inequality symbol in the middle. Yeah, let's simplify the left-hand side and the right-hand side separately. How do you simplify the left-hand side? How do you simplify the right-hand side? Yeah, yeah, exactly. You have negative 7x. You have another negative 7x, right? How do you combine them? Combine like terms is to combine their coefficients. Combine coefficient, negative 7, another negative 7, what is it? Negative 14, yeah? It's like you owe me 7x, and then you owe me another 7x, so you owe me 14x in total. Negative 14x, right? Yeah. Separate Simplify left hand side and right hand side separately. Simplify left hand side and right hand side separately. We need plenty of practice. We have 26 questions in test 2. So you only have 2 minutes for each problem. Right hand side, anything we can combine on the right hand side? 10 and 2, 12, right? Yeah. And then you can try like transposition of terms, or you can apply the addition method. Or do get 8. Yeah. 10 plus 2 is 12. So because left hand side and right hand side are not simplified, we will simplify each side first. Yeah, on the left you have -7x, -7x. Can you simplify it? Can you combine -7x, -7x? Yeah, what is it? Will you combine it? You have -7x and another -7x. Isn't that -14x? Let's say x is an apple, right? -7x means you only 7 apples. And then you only another 7 apples. So you have only 14 apples, right? So you have -14 apples. Yeah. But you still have number 6 on the left. Yeah, you're gonna bring it down. You don't throw it away. +6. Yeah, +6. Yeah. On the right hand side, can you combine 10 plus 2? What is 10 plus 12? Yeah. 10 plus 2 is 12. Yeah. 12 minus 20x. Yeah, very good. So now you did the first step. You simplify both sides, right? And now let's look at the unit parts. We have 1, 2, 3, 4. 4 parts, right? Would you like to try my transpositional terms? Okay. So then you're gonna move this term over. Yeah. Do you change the sign? When you move it over, do you change the sign? No. You move it and you change the sign. -14x. Copy -14x. How about you use a different one? Do you want to get rid of -20x on that? You want to get rid of it, right? So you add 20x plus 20x and the plus 20x here. You have to do the same thing to both sides, right? And draw a line. Okay. So do they cancel? Yeah. So do you have 12? Still have 12 here? You don't throw those terms. Yeah. You still have those. No, you don't have x anymore. -20x, +20x cancel each other, right? They are disappear. And here you have -14x plus 20x. What is -14x plus 20x? You owe me 14x. And you give me 20x. You owe me $14 and you give me $20. So actually you give me how many dollars? $6? Okay, so that's 6x. Okay, you have 6x, but you still have this 6, right? You don't lose them. Yeah, and then that's that. Okay, now do you want to get rid of 6 on the left? Because you want to isolate the x on the left, right? So you want to get rid of this positive 6. You have -6 here. -6 here as well. Draw a line. Okay. So you have 6x on the left. Less than, what is 12 -6? Yeah. And then what do you do? Almost. You want to isolate the x on the left, right? Divide both sides by 6. Yeah. So what do you have on the right? Divide the right hand side by 6 as well. Whatever you do on the left, you have to do the same thing on the right. Yeah, what is 6 over 6? 6 over 6 is 1. So x is less than 1, right? Right? Yeah. How do you graph it? What is it? You have a solution? What for x? Your solution must has x, right? And you have to graph it. And you have to oh, you move this over, okay? Where did you get this thing? Where did you get it? You move the top to the top. You have 6 here. I don't know where to get it. Where's yours? Okay. You want to move this over. Or you want to plus 20x to both sides. Remember, is this a common inequality or not? No, this is a regular inequality. Every time we solve a inequality, I draw a bubble. What do I write in the bubble? Isolate x on the left. Your goal, when you get in your car, you need to have a destination, right? You need to know where you're going. So now when we start to solve this inequality, we need to know we are going to isolate the x on the left. So now you do not isolate the x on the left. You still have x on the right. So you know you can move it over to the left, right? Yeah, very close now. Very close now. Any questions? Yes, awesome. Let's look at this problem together. We always start from simplify each side. Okay, left hand side, negative 7x, negative 7x. We have a negative 14x. Correct? And then we plus 6. So what we did is we combined negative 7x, negative 7x. We didn't do anything else. On the right hand side, we combine 10 and 12, 10 and 2 to get a 12. So we have 12 minus 20x, right? You still have negative 20x on the right hand side. All we did is we combine 10 and 12. So now how many terms do we have? We have blue, green, orange, purple. Okay, which terms are like terms? Blue and purple are like terms or not? Okay, so we want them on the left-hand side. Green and orange, we want them on the right-hand side, right? Okay, blue is already on the left. You're gonna bring it down. You don't change it, you just bring it down. Blue is already on the left. Purple is on the right-hand side. You're gonna move it over, so you have to change the sign to positive. Okay? On the right-hand side, we still have 12. 12 does not change because 12 is already on the right-hand side, right? You want to move 6 over, so you have to change the sign. So the green term becomes negative 6. Okay, what happened is I move this purple over here. It becomes positive. And I move this green term over, it becomes negative. That's what happened. Do you see that? Blue term doesn't change. Orange doesn't change. Purple change the sign. So the sign also changes. green, change the sign. Also the sign is changed, right? Side and the sign is changed. The reason we do this because we need to combine, we need to collect like terms in order to combine them. On the left, 19x plus 20x. What's the answer after we combine them? 1914, 20. What's 1914 plus 20? 6x, right? Yeah. On the right hand side, what is 12 minus 6? Divide both sides by 6. Do we need to switch the direction of the inequality symbol? Because it's a positive 6, right? Graph the real number line. Graph the solution set on the real number line. All the real numbers to the left of 1, right? 1 is included or excluded. 1 is included or excluded. So we have a parenthesis there, okay? So the solution set in the interval notation is an open interval, negative infinity to 1, both open. All right, guys, we are going to have the review tomorrow. And we will have the test 2 on Friday. Thank you, guys. I'll see you tomorrow.